As a hell of an engineer from Georgia Tech, I found some of the concepts in the story Flatland by Edwin Abbott very scientifically and mathematically interesting, and I would like to share them with you. First of interest to me were the methods of recognition between shapes. In my opinion, the method of touch seems somewhat absurd. I see two possible ways this could go in our world.
Touch you? No way. I'm calling the cops.
In the world of Flatland, though, I suppose it would be a socially acceptable thing to do. However, I much prefer the method of recognition by sight. At first I was very confused about how this could work, but upon further thought I realized that this method makes perfect sense. In essence, the technique relies on computing the change in brightness divided by the change in distance. Here we will consider brightness to be the width of the line. We also assume that the brightness of any vertex is the same. For our purposes, we will consider it 1. Abbott states that the maximum length of a side is 12 inches, so we will consider that brightness to be 0. Assuming a constant rate of decrease in brightness over distance, then measuring the change in width and the horizontal distance allows us to apply a little trigonometry to solve for the angle of the shape. If you think this is a lot of work, you would be right. However, it also explains why Flatlanders abhor irregular shapes. This method will only work for regular shapes, so if a Flatlander were to do all of this work only to find out he could not figure out what regular shape this shape is, the Flatlander would be very angry. Going through this process helps one to understand why Flatlanders do not allow irregulars in their society. One other point of interest to me was the law of nature that states a shape shall gain a side with each generation. If the sides only increase, then where do the new isosceles come from, and how is the population of Flatland sustainable? After several generations, shouldn't the Flatlander species die off? For this problem, we will ignore women since they never gain a side, even though women should never be ignored. Assuming Flatland has a carrying capacity, as any environment does, this means that Flatlanders must die at some point. Abbott does not explain what shape comes after a circle, so we will assume that circles are unable to give birth and simply die. We will also assume that isosceles go straight to equilateral, even though we know that they do not, and that circles come after hexagons. This allows us to speed up the extinction process by a few generations. We will also assume that 50% of isosceles stay isosceles with each generation, and 5% of each other shape regress by one side, and 5% of each other shape stay the same by each generation. By applying linear algebra and substituting these values into a transition matrix, we see that as the number of generations increase, the number of dead is equal to 2,500, the initial population of Flatlanders, and the number of each other shape is virtually 0, which shows that the current laws of nature governing Flatland are not sustainable. To me, this is the greatest mystery of Flatland. I hope you enjoyed this analytical look at the world of Flatland. Thank you for watching, and please subscribe if you enjoyed this video.